Today, my groupmate and I would like to explain about the transfer function and the system response. For the methodology part, there are two systems were used in these lab sessions, which is called mechanical system and electrical system. The mechanical system in figure 1 has been shown and the equivalent transfer function for the system was calculated. Formula for the equivalent transfer function are G1S is equal to S1S over Fs, and second is G2S is equal to S2S over Fs. All the given variables were used in our calculations. For the unit step response, it has been generated after obtaining the transfer function G1S and G2S. The system parameter set as M1 and M2 is equal to 1 kg, K1 and K2 is equal to 1 Newton meter, FV1 equal to 2 Newton second per meter, and the last one is FV2 and FV3, which is equal to 1 Newton second per meter. The output response for both transfer function in a same graph plotted. The output response were analyzed and explained. For the electrical circuit in figure 2, the same task as part A has been completed. The input in T and the output is VLT, where the VLT is the inductor voltage, has been given.
In this calculation section, on the first part, which is mechanical system, there are three variables applied in this equation, which K for spring, M for mass, and F for friction. First equation, which M1 is equal to 0, and the second equation equal to F for the output force. Then, by using the Cramer rules, turn the equation into a metric form to find the value of A, A1, and A2. And then to find the transfer function equation, the equation for determinant of A and A1 and A2 need to be found. To find x1, the value of determinant A is over determinant A1 is over A, and for x2, determinant A2 is divided by determinant A. In electrical system equation, there are two loops applied in this equation. By using the mesh analysis, both loop equation was right. And then the same way as the first part, by using the Cramer rules, turning the equation into metric form to find the value of A, A1, and A2. Finally, the value of I1 is the determinant A1 over determinant A, while equation of transfer function for I2 is determinant A2 over A.
So after hearing the procedure and the calculation, we now know that the main purpose for this experiment is to find a mathematical model which is called transfer function for a linear time invariant system, and also to find the output response of transfer function, and is analyzed by using a MATLAB software. At the start of the coding for part A, the value of component has been declared here. As we can see, the value of M1 is equal to 1, K1 is equal to 1, FV1 is equal to 2, M2 is equal to 2, K2 is equal to 1, FV2 is equal to 1, and FV3 equals to 1. Then all the equation for A, A1, A2, and also the transfer function x1, which is the determinant of A1 over determinant of A, and x2, which is determinant of A2 over determinant of A, were mentioned below after the variable section. Besides that, the unit step response for the output was plotted. As a result, that can be observed, the signal shows two different lines of transfer function. The first one, which is red, is for x1 over f, while the blue one is for x2 over f. Based on the result, the unit step response was a little bit slow and do not have any overshoot, while the unit step response was steady state. For the second part, the variable above also has been declared, which is R1 equal to 1, C1 equal to 1, R2 equal to 1, C1 equal to 1, R3 equal to 1, and L equal to 1. Then the equation was defined from the calculation and after determinants for A, A1 and A2 was right. For the plotting session, the same instruction was used as the first part by define the numerator and denominator from the transfer function. So that's all from us. Thank you.